Yeah. Once again, good afternoon, all. Here we started fourth unit. As I told you in the last class, when we are going to design our database with help of normalization card rules, if your database is good, then we can apply the transaction management system. If your database is not following the rules and regulations from the database management system, we cannot imply the transaction things. That is why here I thought everyone is done your all the works, whatever I assigned means ER diagram, relation model, and uh, normalization and SQL queries. Then we can apply our transaction management system. So this is very important. If we are going to miss anything in this process, we cannot get uh, what I can tell transaction things on this uh, your database. So that if really if you are not done your laboratory, anything is missing by the next week, please do it, and we can go for our triggers and everything. Even we discussed about triggers in the last lab. Uh, we will continue that in the next week also. Now, as we discussed in the last class, that is what is a transaction and how the transaction will work and what are the real-time examples of the transaction management system, really where we are using and how it is going to help, and what are the acid properties which we are going to use for transaction management system. All these things, basic things we covered in the last class. Can anyone tell what is a transaction? Any one of you, please? What is a transaction? Hello?
A set of actions.
Yeah. Set of sequential actions which are performed given order. That is also very important. Because if you are going to transfer amount from A account to B, compulsory you need to read A and deduct amount from A and write A, then read B, then add that amount to B, then write B. This process must be in a order. These are every operation is an action, and one by one it must be executed, so that it is a collection of sequential actions which are going to execute given order. So this is what exactly the transaction. Clear? Clear?
Yes, sir.
Yeah. Now we discussed a lot of things in the last class. Then just we are continuing the last class, and even we discussed about the acid properties. Can anyone tell what are the acid properties are there? What are the acid properties are there? Very important. Everywhere people will ask. What are the acid properties are there? Hello. Even first unit also we discussed in that. Differences between file management system and DBMS. That also the main these asset properties are there in DBMS that is not there in the file management system. Tell me any one of you, what are the asset properties are there in this transaction management system? Hello, quickly, don't waste the time. Sir, we discussed this asset properties half an hour, I think, in the last class. You said, okay, okay, sir, we understood. Now, one, yeah, If I am asking, then you are not telling the answer.
So atomicity,
Hmm. Very good.
D
Atomicity.
for durability,
Hmm.
I is for isolation, and
Hmm.
C is for consistency, sir.
Right. You are telling reverse. Okay, no problem. Atomicity, consistency, isolation, durability. As a very important, I am telling. Atomicity, consistency, isolation, durability. If you know these four rules, you can understand complete fourth unit. Because only because of these four rules only the transaction will be done. If all any transaction is not having this acid property, the transaction is not successful. The transaction is a failure. The transaction is having error. Means if any transaction will be done, the transaction must be contains atomicity, consistency, isolation, durability. If any one of the rule property is missing that particular transaction, the transaction is an error. The transaction is having some problem. Understand? Hello? Have you understood? If you are prepared any transaction that must be follow these acid properties, atomicity, consistency, isolation, durability, which I told in the last class. Understood?
Yes, sir.
So that is why complete fourth unit is depending on atomicity, acid properties. Now tell me, here with example I explained in the last class. Just tell me what is atomicity. Respond quickly. What is an atomicity? What is an atomicity? Quickly. Hello. Acid properties are understood in the last class or not? If not, I will explain again. Hello. Please don't waste the time. All of you understood acid properties in the last class or not? If not, I will explain. If understood, tell me what is atomicity. Unnecessary, don't waste the time. Quickly. Hello. Shall we continue the class or not? Shall I continue? No one is responding. What is going on? Do you understood acid properties in the last class or not? If not, I will explain. If yes, then tell me what is atomicity, what is consistency, what is isolation, what is durability. Because this complete fourth unit is depending on these rules only. Try to understand the situation quickly.
Atomicity means either full execution is done or no step will be done in the process.
Okay, good. Consistency,
Is there consistency in the database or not?
isolation, what is isolation?
When different
Transactions
transactions are
being
run,
done.
they should not get affected by each other.
Yeah, right. Durability,
The amount before deduction and after deduction must be same.
Then all are right. Why you people are taking this much time? You people are testing my patience. Anusha, Yogita, and someone is texted in this Saikiran. Why you are not responding quickly? Tell me. Okay. As per your answers, I thought you understood, right? Yes or no?
Yes, sir.
Yeah. So, asset properties here because this is very important. That is why I am asked. I taken this much time for asking. Right. How really how asset properties will work one by one. We'll check. As I told you in the last class, atomicity already. Uh, some of the students, few of students are given the answer same, right? 100%. Your atomicity requirement. If, for example, if you take this is a transaction. Already I said. Already you know, transaction is a collection of actions which are going to execute sequentially. First action, second action, third, fourth, five, six, like that. Read A equal A minus 50, write A, read B equal B plus 50, right? It means you are transferring $50 from A account to B account. This is the transaction. Clear? Clear? Hello? Response is required. I told you, otherwise I cannot continue. Is this clear? Already I
Yes,
told
sir.
you transaction is a collection of read and write operations, right? Yes. Now atomicity, as your definition just now, here if you execute this transaction, it contains some of the actions, all actions must be execute. Otherwise, it must be starting stage. It never be in a middle. Means, with example, if the transaction fails after step 3, then after step 3, maybe there is a failure has happened, okay, or before step 6, maybe after step 3 or before step 6, maybe the transaction is going to failure. Money will be lost. Who is going to lose money? Who is going to lose?
Sender.
Sender. Means A is in this transaction, A is going to lose the money. Yes or no? Yes or no? Hello? Hello? In
Yes,
this
sir.
transaction, yeah, please respond quickly. Now that the failure may be happened because of fire accident, hardware problem, software problem, that is immaterial to us, whatever it is. Then atomicity will tell, it will tell the transaction must be execute or the transaction must go to the start. Maybe the error will come here, the failure will come here. It moves to the beginning. Here before 6, any failure is going to happen. Then atomicity will tell, no, no, here we are in the middle of the transaction. Just go to the beginning of the transaction. That is what the system should ensure that updates of a partially executed transactions are not reflected in the database. Yeah, that is the duty of the atomicity. Clear? Clear? Just I am showing with example, I am fulfilling the asset properties. Now clear atomicity? Again with example. Hello?
Yes, sir.
Yeah. Now durability. Already just now one of the girl given the definition of durability. That is before what is the value is there, before transaction what is the total value is there, after transaction the value must be saved. That is what durability means. There is no data loss. Means once the user has been notified that the transaction has completed. Here, if the transaction has completed means here $50 from A transferred from A to B. But before transaction, how much dollars are there with A and B? After transaction also, the dollars are same from A and B. That is what after transaction completed means the $50 are transferred. The updated to the database by the transaction must persist even if there are software or hardware failure. Even any failure is happen also, that must be same after the transaction or maybe the before the transaction, the value must be same. That is the duty of the durability. It always checks that particular database here that is a durable or not, durable or not. Anything is going to miss, then it will be notified. Here, this is what exactly the durability of the transaction. Clear? Clear? Hello?
Yes, sir.
Yeah. Now, consistency requirement. Here, as I told you earlier, same transaction I have taken here. Here, consistency. The sum of A and B is unchanged by execution of the interaction transaction. Here, when we are processing your transaction, the sum of A and B is unchanged. Compulsory that must be same. If something is changing A plus B, then that is not a consistency. Here, compulsory that must be a same. In general, the meaning is explicitly the specified integrity constraints such as primary key and foreign keys, implicit integrity constraint, sum of balances of all accounts minus sum of loan accounts must equal value of cash in hand. Simple. Means here whatever the operations you are perform in this transaction, the sum of A plus B, how much it is there. At the time of transaction also, A plus B must be same. Means in every case, the A plus B, sum of the A, B values must be same. In any case, that is called consistency. Here, that is going to check by the consistency. A transaction must see a consistent database. If anything is going to miss, now this consistency always checks are informed to the transaction. Clear? Clear?
Yes, sir.
Now isolation. Here actually individually if you refer consistency, some meaning will come. When after understanding the isolation, here some more information you will get for this consistency. I will tell you. Here only one transaction here I have taken. So that this type of information, this type of knowledge you can gain. When you take isolation is nothing but here we are having more number of transactions, T1 and T2. Now, when we are going to means at a time multiple transactions. Here, when we are performing a transaction, here T2 is never affected to T1. T1 it must be never affected to T2. Means T2 will be execute independently and T2 also execute independent. Means it is not depending. T2 is not depending on T1. T1 is not depending on T2. That is called as isolation. Understand? Understand?
Yes, sir.
If T1 is not depending on T2, means T1 is getting consistency because it is not depending, it is not requiring any data from T2. So that T1 will get the consistent. Means the consistency also depends on the isolation. If the transactions are more, then those transactions must be executing isolation way so that we can achieve the consistency. Understand? If in your database more number of transactions are there, then all transactions are working in the isolation way so that indirectly you can achieve consistency because it is not depending, it is not disturbing to other transactions. Uh, for example, you are you are entering one ATM machine. Parallelly, two, three ATM machines are there. You all your friends are doing the transaction, same ATM machines. For example, you take it all HDFC five your friends are entered and you are taking the transaction. You are entering your card. All your friends are entering your card and they are transaction. You are going to withdrawing 5,000. Your friend 6,000. So on. So. But here, whatever the amount you are withdrawing, that is deducted by your account only, not from your friend account. You are entering your PIN, you are accessing only your account. You cannot access your friend account because all are processing in the same time, all are doing the transaction same time. You are going to feel like that, but it is not possible. It is not possible because of the isolation. If because there is only one object. Now at a time, if you are doing one transaction, for example, your parent, this is your account, your parent is transferring 10,000 to your account is having 5,000 basically. Now they are at the same time you are withdrawing 3,000. Now when we are doing two processors at the same time, now it is not possible. Here we are your parents is depositing 10K and you are withdrawing 3K. Here how this is going to do? No. First maybe you are going to withdraw 3K, or maybe this deposit is going to done first, so that only you can get the how much balance is there in this account. Means maybe if you take the first choice, that is what your operating system scheduling algorithm, first come first serve, last latest job first, all shortage job first, priority scheduling. Here I think 4 to 5 scheduling algorithms are there. Same way here also the transactions also having here, which one we need to take first, that we can discuss later, don't worry about that. Yeah, that is what exactly, if it is take first depositing as a first action, then 15,000 is their balance, then from 15,000 you can withdraw 3K. Otherwise, you can withdraw first, then it is going to deposit. Yeah, that will be done. That's why here this transaction is not depending on this transaction. This transaction is not depending on this transaction. So that only we can get the that is called, it is isolation. If you do that is isolation, there is no data inconsistency. There is a consistent data. If you perform both 10,000 depositing, withdraw 3,000, how can I know this balance? Tell me, is it possible? Both actions will be performed same time. Can you understand what is the balance? Hello? Hello? Is it possible?
No.
No. Means that is inconsistency. Yes or no? If we perform two transactions at the same time on say single object I am telling. For example, your parent is transferring 10K to your brother account, you are withdrawing 3K from your account. Okay, different objects. We can do a number of operations. But if it is the same account, there is a inconsistency. Yes or no? Yes or no?
Yes, sir.
Yeah, means the consistency we can achieve, the transaction must be in a isolation way. Understand? Means isolation way means here this transaction is not depending on this transaction. This is maybe the first, this is the next. Our first next means which is not depending on other transaction. That is the isolation. Now we cannot get any inconsistency problem because of the isolation. Understand now? Understand?
Yes, sir.
Yes, sir.
For example, here, based on this example, we can understand. Now, T1 transaction read A equal A minus 50, write A. Here, after write A, okay, up to this, okay, A is updated. But after that, two transactions start. This gap means T2 transaction is going to start. Here, this is up to T1. Now, T2 is started. What here we have written here after this break, read A, read B, print A plus B. Here, read A. Is there any problem for reading A? Because write A is over, right? From T1. Now T1 is not there, A is not there with the T1, right? Yes or no? Hello? Hello? Sir,
Yes, sir.
T1 is performing read A equal to A minus 50, write A. Means sir, A is updated from T1. Yes or no? Now A is not with T1. Yes or no?
Yes, sir.
Yeah. So that A, then we can access A by T2. Is there any problem?
No problem.
No problem. Because T1 is now, it is not working in this period. So that, please understand, then only we can understand transaction management. Now read again, read A, then read B. Here B. B is not having T1, right? Now, in this time, in this period, here B is not accessed by T1. Yes or no? Yes or no?
Yes, sir.
Then print A plus B. So it will be success. Now, this T2 is not depending on T1. Yes or no? T2 transaction is not depending on T1. Yes or no?
Yes, sir.
Then after these operations by T2 transaction, now T1 is started. Read B. Now in the same period, T2 is not accessing B. Yes or no?
Yes, sir.
Now B equal B plus 50, write B. So that T1 is, in this case, T1 is not depending on T2. Yes or no? Yes or no? Hello? Is this clear?
Yes, sir. Clear.
Yeah. So that there is no chance of any inconsistency. If these transactions are executing isolation way and these transactions are executing serially, means T1 is executed their operations, then T2 is executed their operations, then again T1 is executing serially. First, second, third. So that serially it is executing one by one. So that these are isolation transactions. If you do the transaction in isolation mode, then we can achieve the consistency. Clear?
Yes,
Clear?
sir.
Yes, sir.
Yeah. Here one problem is there here. Okay, this is isolation and consistency. But nowadays, here we are working on concurrency execution, not serial execution, because here everyone we need to do multiple transaction. We are doing multiple things at a time. So that is there. Okay, we will discuss this concurrent transaction execution in the next sessions, because concurrent transaction executions will give a lot of advantages. How we can make it concurrency mechanism with help of asset properties. I'm telling again, here without asset properties, we cannot do anything in a transaction management. Here with inclusion of asset properties, here there is a chance, there is some mechanisms are available in transaction management system with concurrency transaction, concurrency management. How we can do that, we will discuss later. But initially, we need to learn serial. Clear? Clear? All of you clear?
Yes, sir.
Yeah. Now, next topic, very interesting and important topic, and complete transaction is depending on these states. Your transaction states. Generally, when we are going to execute transaction, it contains five states. It contains five states. Here, initially, the transaction is in a active state. Here, the active state is nothing but is a initial state, means starting state. Here the transaction is stays, maybe it will be there in this active state until the transaction is going to executing. Here when it is moving to execution process, until the transaction must be active, means the transaction maybe in back so many transactions are there. those transactions are in a queue. One by one, it is going to execute. You know, operating system, we have to wait some data in a queue. That is a waiting queue. You know very well in a operating system. Yes or no? Hello? Whatever the jobs, there maybe they are called processes or jobs. But here we are going to call it as a transaction. That is the terminology is different because this is a financial things and all these database things. But the procedure mechanism is same. Are you clear?
Yes, sir.
Right. Now, active state means the transaction. When it comes to the entering into the transaction mode, now it will be become as a active. Otherwise, these are inactive states. Now the transaction is entered in the active state. Active means now it is ready to execute. It is not started execution. It is ready to execute. When the choice came to active, then here two choices are there from active state to two choices. One is partially committed and failed. Here before learning partially committed and failed, I will tell you what is commit, what is abort. Here, commit means the transaction executed successfully. Means here, here all these operations are going to execute successfully. That is called commit. Transaction is committed. Means, for example, you are entered into the ATM machine. You are given your entered your ATM card and you are given PIN number and everything. Here, after some time, you are entered 5,000 to withdraw, but your account is having only 4,000. Then it will be show insufficient balance something. The error has came. Then the transaction is actually the transaction is completed, but unsuccessful. The transaction is having number and everything you will get. The transaction number also you will get. Yes or no? Yes or no? Your attempt is done. Hello? In that ATM machine, your attempt is done. The transaction number is generated. The transaction is completed but unsuccessful. The transaction is unsuccessful. Yes or no? Transaction executed unsuccessfully. Yes or no? Hello? Please
Yes, sir.
respond. Yeah. The transaction executed unsuccessfully means any failure, power failure, or maybe you are entered wrong PIN number, whatever it is. That the transaction executed, I am telling the means you are doing something means there is a transaction. But that is unsuccessful means that all actions are not performed means acid properties are not satisfied. That is called transaction unsuccessful. If the transaction unsuccessful is called as abort. The transaction executed unsuccessfully is called as abort. If the transaction is executed successfully, means all actions are performed successfully. All actions means you have taken your money from your account. Here, that is a transaction executed successfully. The statement is committed. The committed is nothing but the transaction is executed means all actions are executed successfully. That is committed. Transaction committed and transaction aborted. Transaction aborted is nothing but transaction executed unsuccessfully. Transaction committed is nothing but transaction executed successfully. Clear? All of you clear?
Yes, sir.
Yeah. Now, from active state, we have to basically two things. One is committed, another one is the abort. Please remember, here maybe the complete all actions are executed successfully. We can move to the committed state. If any action is going to not done, that moves to the abort state. Nothing but transaction executed successful, transaction executed successful. Clear? Clear? Hello?
Yes.
Yeah. Now, once the transaction is active, now what happened? Just we are entered read A equal to A minus 50, write A. Now we are here. Means some of the part of the actions are done. Part of the actions are done. Yeah, that is a partial committed. Means some more actions are there remaining. 4, 5, 6 actions are there. Okay, that is a partially committed. For example, I entered ATM machine into my uh, debit ATM card, ATM debit card. Now, after that, it is going to ask PIN number I entered. So that it is going to ask options. I've taken savings account. Now it is asking to enter amount. I have not given. Just I am waiting 1 second. Yeah, now that is called whatever the information previously I given, that is right. So that the transaction is now where it is partially committed. Understand? Because whatever the operations I done previously, yeah, these are right. So that it is waiting here. That is a partially committed. Understand? Hello?
Yes, sir.
Now I entered instead of ATM card, I entered a visiting card into the ATM machine. Here, please remember, I entered a visiting card instead of ATM card. Then so the transaction is came active. Now I entered visiting card. Now the transaction is a partially committed or transaction is failed. Tell me. Transaction is partially committed, partially it is failed. Hello. I
Yes, sir.
entered. I entered in my not ATM card. I entered another card. Now the transaction is from active to partially committed state. It will be moved or partial active state to failed state. It will be moved.
Failed.
Failed state. It will be moved. Once the transaction moved to the failed state, then directly it moves to the abort state. Please remember. Once the transaction moved to the failed state, there is no other option. Here, once the transaction is moved to the failed state, here directly it moves to the abort state. Means transaction is going to get failed. Clear? Transaction is executed unsuccessfully. Clear? Hello? Are you clear?
Yes, sir.
Yeah. Now the transaction is there in a partially committed. Means some of the actions are right. Maybe 3 actions are given. All these 3 are right. So after this, it is asking now enter money. Here my account is 10,000. It is having, but I want to withdraw 12,000. Now I entered 12,000. Then up to this, the transaction is partially committed. When I entered 12,000 to withdraw, what happened? There is no chance to move to commit, right? Because if it is committing means it is going to provide 12,000. Yes or no?
Yes, sir.
So that the transaction is moved to failed state. Understand? So that the transaction is moved to partially committed to failed state. Yes or no? Your ATM machine is going to give. Your account is having 10,000. You want to withdraw 12,000. Is it possible? When you are given all these options up to this partially committed, once you enter 12K to withdraw, it is moved to the failed state. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah, it is failed. Once it is moved to the abort, your ATM will come out, the transaction is failed. But if you are given 10,000, your account is having, you are withdraw 10,000, then it moves to the committed state. So these are the 5 states in a transaction when you want to perform active, partially committed, failed, committed, abort. Here, if you observe, any transaction is moved to the failed state, so directly it moves to the abort state only. But any transaction is moved to the partially committed, so there is 2 choice. One is committed, another one is the abort also. Yes or no? Yes or
Yes,
no? All of you clear this? This is very important. I am telling. These transaction states are very important. Transaction is having 5 states. Your active state means initial state or starting state. Your partially committed state is nothing but, as I told you, some of the actions are executed successfully, then mission or maybe the transaction is waiting for next following action. That is after the final statement has been executed. That is what exactly the partially committed. It is waiting for the final statement. Now next one is a failed. Here after the discovery that normal execution can no longer process. Exactly. That cannot be continued. That is a failed state. Abort state already I told you, that is after the transaction has been rolled back and the database restored in the state prior to the state of the transaction. You kill the transaction for this aborted. Your committed means the transaction is executed successfully. Already told you. So these are the 5 states. So when you are going to write any transaction program, the program must contain these 5 states. So based on these 5 states only, our transaction will be implemented. Clear? All of you clear? Transaction states very important. You can expect one question from here in your external examination. All of you clear about this transaction states? Hello?
Yes,
Hello?
sir.
Yeah. Now, implementation of atomicity and durability. So based on this transaction states, so how we can implement the atomicity and the durability. So the recovery, especially, any failure is going to happen. Here we need to recover. Why? Because, for example, here I transferred amount A to B, that is $50 I deducted. Then I wanted to add this 50 to B, right? So this is what exactly the transfer. Now after deduction, maybe the failure is going to happen. Okay. If the failure is going to happen means it is atomicity, it will tell now it is not followed atomicity. Now so that it will be tell it is in the middle, so that it is going to inform. But it is informing to the transaction, but anyway $50 are going to loss. Now who is going to recover this? Here we have in fourth unit in the transaction the recovery management system. Here in transaction management, along with the transaction management system, any data is going to loss. Here acid properties are going to verify here where the loss is happened. So that is going to recover with help of recovery manager. So that is what exactly the recovery manager we will discuss. Don't worry about this. Are you clear? The recovery manager is clear. Means wherever the data is going to loss, means it is loss here. Here after A minus 50. The recovery manager is going to recover, means moves back, and moves to the, as per the atomicity, it moves to the start state. If it is in a start state means that 50 again back to A. Back. We are deducted $50 from A. Again we are moving back, means 50 added to A. That is what the based on atomicity, acid properties, our recovery manager will be work. That's why acid properties are very important. Now understand recovery manager means, so many techniques are there, so many algorithms are there. Just basic technique I told you, we will discuss one by one. All of you clear? Recovery management means, hello? All of you clear this recovery management? Yeah, in depth with example we will discuss, but initial things please understand because these things are going to help. Okay, now for this shadow database is one scheme actually very important. That's why they given in your database management system. So this shadow database is one of the recovery management scheme. It is a basic level recovery management scheme, and it is not suitable for a bigger databases. It is suitable for only small databases. Real-time applications maybe it is not suitable. Then how it will work I will tell you. Here in a shadow database scheme, there is a database pointer, DB pointer is there. Always this database pointer points to the current update. Current means here whatever the data it is there, here that is going to show. Means here in this shadow database, what happened? Here it is going to store one by one by one. For example, here before updation any data means updation is not done. Here this is old data it is pointing. Now one update is came, then the database pointer is pointing to the current updated data. If you are updated some other data, then what happened? Here it is pointing to the current data, but it maintains old data also sequentially. Are you clear? Are you clear? Hello? Shadow database scheme is nothing but shadow means maintaining the old data sequentially. There is a database pointer, it is points always current data. This is the structure of shadow database. All of you clear? How recovery manager will work? Basic recovery management system I am telling that this shadow database as an example I am telling, and how to get the atomicity and durability with shadow database management system I am telling. Atomicity is nothing but here any failure is going to happen, it complete or maybe the first. Durability is nothing but here before after transaction the data value must be same. So that is what. All of you clear this? Shadow database? Hello? Structure I am telling, all of you clear? Right. Now any failure is happened. For example, one failure is happened here. Transaction is performing, some failure is happened. Here now, what is the rule? As per the atomicity, in middle it cannot be stopped. If it is going to stop in a middle, your atomicity will tell go to the starting position. So that here the database pointer pointing to its previous data, because already it is maintaining the shadow database is maintaining all previous data. Again, the transaction is performing like this, any failure is going to happen, again it moves to the its previous. Here like that, here the shadow database is maintaining all the data as a one copy for with updated data, but always the database pointer pointing to the current data. If it is doing like this, so that we can achieve the atomicity. If we are getting the achieving the atomicity means automatically durability will be achieved. Always durability is depending on atomicity. Why? Because here if you are performing your transaction, here the failure is going to happen. Means atomicity is not satisfied. What is the meaning of atomicity? You need to perform all the tasks in the transaction, or you must be in the starting position of the transaction. If you are at here, the durability is same. Means before transaction, A and B accounts are having same data. Here, if you are here, the durability is there. So that the durability always depending on atomicity. So that if you get the atomicity, automatically durability will come. Yes or no? Yes or no? Hello? Hello? Hello?
Yes, sir.
Hello? Are you clear? This shadow database is clear.
Yes, sir. Clear.
Now, why you are not responding? I'm unable to understand today. Right. Now, whatever I told you, the theory is there. Database pointer always points to the current consistent copy of the database. In case transaction fails, old consistent copy points to be DB pointer can be used and shown shadow copy of to be deleted. Now, the shadow database scheme assumes that only one transaction is activated at exactly because always database pointer pointing to only one shadow copy. Disk do not fail. Assume disk do not fail. Exactly, disk do not fail. So that is what exactly it does not handle. Already I told you, extremely insufficient for large databases. So this shadow database mechanism, it is not suitable for big databases, because if the database is big, then you need to maintain these copies are big. If you are maintaining these copies big means your machine is not going to handle that much of data. So that this shadow database is not suitable for large databases, so that only small database and only academic related databases we can use this particular shadow database. That is a one disadvantage. Another disadvantage is does not handle concurrent transaction. Here it is not going to handle the concurrent transaction because as I told you, this database pointer always pointing to only one transaction at a time. If it is failure, it is going to back. Means only one will be run. Means sequentially it will be done. There is no chance of concurrent. Means this data pointer cannot be pointed at a time three. That is why it is not suitable for concurrent transaction. Sure, because of the concurrency, we can get more accuracy, more fast, more usable. Because always we are going to think, I need to perform all the actions at a time. Yes or no? Nowadays we are doing all the actions at a time. Yes or no? Yes or no? Your machine also doing multiple transactions, multiple actions. Yes or no? You are listening, you are watching, and you are doing some your WhatsApp, you are typing something. All these things you are doing with the help of your operating system. That is what multi 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 multi-purpose operating system. Yes or no? Hello?
Yes, sir.
In the same way, our database management system also must be handled concurrent transaction management system. But this shadow database scheme is not possible to handle the concurrent transaction. That's why this mechanism is not right mechanism for recovery management. Only small things we can use for this. Okay. We will discuss concurrent executions in the next class. Here, what is the concurrent execution and what are the advantages of concurrent execution and how to solve these concurrent executions, all these things. All of you understood